Hi, so this short video is just going to talk you through fractional distillation and nothing else. We're going to be looking at how crude oil is made useful, and specifically from this video, you're going to be able to explain how crude oil separates into different fractions. So if we remind ourselves, crude oil is a thick, very viscous, black liquid technically, but it's very, very thick, that's dug out of the ground, generally under the sea, and is a mixture of lots and lots and lots of different useful products. Now, in the form we get it out of the ground, we can't use it for any of those. It's very hard to ignite. So one of the main uses of these, the products of it are that we burn them for fuel. Now we can't burn crude oil, it just won't ignite easily. So we've got to separate it to make it useful. Now, as we know, the products that we get are alkanes, and the longer the chain alkane, the higher the boiling point is. And this is the key fact that makes fractional distillation work. So we separate crude oil into its fractions based on the boiling point of each different fraction, different group of substances. So let's see how it works. So we've got an example there of what a fractionating column often looks like in a simplified diagram. These fractionating columns are often 10-story high buildings, very, very tall, very wide columns to allow the crude oil to separate into its different fractions. So the first thing that happens is the crude oil is heated to about 350 degrees C, and the whole point is that it's vaporized. We want it to turn into gas. Now, not all of it will turn into a gas. Some of this will be a residue that then remains as a liquid and is removed from the bottom, and that is used for roads, for the tar on roads. Now, because we've got this mixture of hydrocarbons, everything inside it has got a different boiling point. So the vapour means that everything that goes into the column is a gas, and the column is different temperatures. So the crude oil vapour enters the fractionating column at the bottom. So you're looking at the diagram, it is the bottom left hand side, and the column is colder up at the top than it is at the bottom. So the vapour, because it's a gas and warm gases, they rise, the vapour rises up the column. Now, due to the temperature difference, so as it rises up the column, some of the hydrocarbons are cooled to just below their boiling point, and when that happens, they will then condense into a liquid and they can be removed at the side. That liquid is then collected and is used for whatever purpose. And this carries on all the way up. The gas continues to rise until it turns cold enough to turn another fraction from the gas into a liquid, which is then collected off to the side of the column. So as you go up, shorter chain hydrocarbons are condensing because they have a much lower boiling point than the longer chain hydrocarbons at the bottom. Now, as you can see at the top, some of the hydrocarbons, their boiling point is so low under room temperature that they remain as a gas, and these are removed from the column at the top as a gas. And this is what goes into bottled gas, things like propane and butane. So if we look a little bit at the properties of these different fractions, so at the top, you've got your short chain molecules. As you go down the column to where the hotter end of it is, you have the longer chain fractions with the higher boiling points. So the shorter chains, the bottled gases, you've got propane and butane used for patio heaters and barbecues and camping stoves, things like that. Then you move down and you need to know the order of this. So you've got your bottled gas, you've got your gasoline or your petrol in England, naphtha, kerosene, diesel oil, fuel oil, and then your residue at the bottom. So key points to note from this, that at the top, lower boiling point, smaller molecules, very volatile. It means they evaporate easily, they flow easily because they have low viscosity, and they ignite very easily. So as we know, petrol in a car, propane in a barbecue, the whole point is that they ignite, they set fire to easily. Now at the bottom, you've got larger molecules, long chains of the hydrocarbon with high boiling points. So they're the exact opposite. They're not very volatile. They don't flow very easily because they have high viscosity, and they do not ignite easily. So these are the key points that you need to know about fractional distillation in order to be able to answer questions on it.